Okay, in this question, we have been given acceleration as a function of time. We're told it passes through O at t equals 0 with a velocity of minus 18 meters per second. So, part 1, we're asked to work out an expression for velocity at any time. Now, we know the velocity is found by integrating the acceleration with respect to time. So you can see that we integrate through the integral of 6t will become 6t squared over 2, which is 3t squared. The integral of 3 is 3t, and always remember to add the constant of integration. Now, the initial information told us that at t equals 0, v is equal to minus 18, so I can substitute that in to find the value for c. As you can see, c is equal to minus 18, therefore the velocity is equal to the 3t squared plus 3t minus 18. Okay, part 2. We're asked to show that p changes its direction of motion only once. So that means that we're looking at the case where velocity is equal to 0. So we substitute 0 in for velocity, as shown, and then we want to solve the quadratic equation. Now we can see the 3 divides into all of the terms, so we can factorise that through. And then we have a quadratic. Now you may factorise this by recognition, but a technique is to use multipliers and adders. The multiplier is minus 6, the adder is 1, so the combinations that can make that would either be 1 and 6 and 3 and 2. Because we definitely have a negative value in there, however, one of the numbers must be negative. So it can't be 1 and 6, and it must be 3 and 2. 3's got the bigger influence, therefore it's positive. So we factorise to give t plus 3 and t minus 2. Solving that gives you t values of minus 3 and 2. Obviously minus 3 is not possible, so t equals 2 is our answer. In part 3, we're asked to find an expression for the displacement of p from O at any time t. Therefore, again this time we find the displacement by integrating the velocity with respect to time. We've already worked out the answer from before, so we integrate the 3t squared plus 3t minus 18. When we integrate that, we'll have 3t cubed over 3, which will just simplify to t cubed, plus 3t squared over 2 minus 18t, and remember the constant of integration. Now, again we were told at t equals 0 it passes through O, so therefore when s is equal to 0, t is equal to 0. And when I substitute that, I can see that c is also 0. Don't forget to write out your answer. Okay, now part 4 really probably is the trickiest part. We're asked to find the total distance travelled between t equals 0 and t equals 4. Now notice it is distance travelled and not displacement at that point. So we need to be aware of any point that the direction changed, and we've already established that happened when t was equal to 2. So I'm going to have to find the displacement at t equals 0, t equals 2, and t equals 4. So initially we know that t equals 0 and s was equal to 0. So let's work out what happens at t equals 2. Using the displacement formula, we'll get the 2 cubed plus 3 lots of the 2 squared over 2 minus 18 times 2, and we can calculate that value to be minus 22. Okay, now I need to deal with what happens at t equals 4. So again, we substitute that into our displacement formula. Just careful when you're working with squares. That value comes out to be equal to 16. Okay, So what I would attempt to do is do a diagram to illustrate what's happening. So we start off at t equals 0 and the displacement equals 0, and then at t equals 2 we went to minus 22, and then at t equals 4 went all the way past that again to 16. Now the total distance travelled is indicated in the pink, so I must have covered that distance of 22 twice, and then we add in also the 16 from 0 to 16. Therefore, the total distance travelled is 60 metres.